question is, we have to evaluate x plus 3 upon x square minus 2x minus 5 dx. Now to solve this question, first of all we take the given integral and on observing this integral, we see that the integral is in the form of a linear term of x upon the quadratic term of x. Now to solve this, I am going to place x plus 3 as equal to lambda times d upon dx of denominator plus mu. Right? On differentiating x square minus 2x minus 5, I am going to get 2x minus 2. So I can write x minus 3 as equal to lambda times 2x minus 2 plus mu, which is my equation number 1. Okay, now I'm going to separate here the constant term and the term of x to obtain the expression like this, and on the left hand side the coefficient of x is 1, and on the right hand side the coefficient of x, you can see here it is given 2x lambda. In other words, 2 lambda multiplies with x, so coefficient of x is 2 lambda. So I can equate 1 is equal to 2 lambda. That is, on comparing the coefficient of x, I can write 1 is equal to 2 lambda, or lambda is equal to 1 by 2. This is my equation number 2. Okay. And on equating the constant term, I am going to get 3 is equal to minus 2 lambda plus mu. Substituting the value of lambda in equation number 3, I get 3 is equal to minus 2 into 1 by 2 plus mu. This will be equal to minus 1. So 3 is equal to minus 1 plus mu, or mu is equal to 4. Substituting the value of lambda equal to 1 by 2 in equation number 1 and mu is equal to 4 again in equation number 1, I get x plus 3 is equal to 1 by 2 times 2x minus 2 plus 4. You can mark this as equation number 1a. So taking this equation and the integral, I substitute x plus 3 as equal to 1 by 2 times 2x minus 2 plus 4. So on placing the value, the integral will become like this. Now you can see the numerator, it contains 2 terms. Okay, so I'm going to divide this denominator separately with these 2 terms to obtain these 2 integrals. Okay, I mark them as I1 and I2 because they cannot be solved directly. Okay, and I have also to solve them separately because they involve substitution. So the substitution would be different for both the integrals. So I am taking them separately to solve. Okay, so taking I1 is equal to 1 by 2 2x minus 2 upon x square minus 2x minus 5 dx. Now you can see here that on differentiating x square minus 2x minus 5, I get 2x minus 2. So therefore substituting x square minus 2x minus 5 as equal to t and differentiating both sides with respect to x, I get 2x minus 2 dx as equal to dt. Right? So this I am going to replace with dt. So I am going to obtain 1 by 2 dt upon t. Now integration of 1 upon t is log t. So this will be equal to 1 upon 2 log t. Placing the value of t, that is x square minus 2x minus 5, I get I1 as equal to 1 upon 2 times log of x square minus 2x minus 5. Okay, now I'm going to solve for I2. I2 is equal to 4 upon x square minus 2x minus 5 dx. So it is a constant value upon x square minus 2x minus 5, that is a quadratic expression. So the idea to solve this is to write this quadratic expression as the squares of a variable term and a constant term in terms of a difference or a sum. Okay, so taking x square minus 2x minus 5, the coefficient of x square is 1. So I take the coefficient of x, that is minus 2, neglect the minus sign, so I have 2 divided by 2, I have 1. So I'm going to add 1 square and subtract 1 square from this expression. So the expression would look like this. So x square minus 2x plus 1 square minus 1 square minus 5. Okay, these 3 terms can be written as x minus 1 whole square minus 6. or this can be written as x minus 1 whole square minus root 6 whole square. Okay, this value I'm going to substitute for x square minus 2x minus 5. This will give me I2 as equal to 4 upon x minus 1 whole square minus root 6 whole square. Now to solve further, I'm going to substitute x minus 1 as equal to t. Differentiating both sides with respect to x, I get d upon dx of x minus 1 as equal to dt upon dx, or dx is equal to dt. Okay, so replacing x minus 1 with t, I'm going to get this as t square, and dx with dt, I'm going to obtain I2 as equal to 4 upon t square minus root 6 whole square dt. Here it is dt. Okay, so using the formula that integration of 1 upon x square minus a square dx is equal to 1 upon 2a log of x minus a upon x plus a, I can write this as equal to 4 upon 2 root 6 log of t minus root 6 upon t plus root 6, and replacing the value of t as x minus 1 and simplifying or cancelling 2 with this 4, that is I'm going to obtain to the numerator here. I can write this as equal to 2 upon root 6 log of x minus 1 minus root 6 upon x minus 1 plus root 6. So having calculated the value of I1 and I2, I take both these values. I've started the integration of this function. I've written as equal to I1 and I2 like this. What I have to do, just I have to place the values of I1 and I2 to get the answer. So integration of x plus 3 upon x square minus 2x minus 5 dx is equal to 1 upon 2 log of x square minus 2x minus 5 plus 2 upon root 6 log of x minus 1 minus root 6 upon x minus 1 plus root 6 plus c, which is my required answer. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.